Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper trending on X, published on July 23, 2025, exactly a week ago. This paper introduces a new method that achieves up to a 28% relative improvement on the HealthBench 1K benchmark compared to simple rating scale approaches. The paper is titled Rubrics as Rewards, Reinforcement Learning Beyond Verifiable Domains, and the implications for training models in complex, subjective areas are pretty significant. The core idea is to use structured, checklist-style rubrics as a more interpretable reward signal for training. Okay, and the authors themselves have been highlighting a few key points from their work online. The main takeaways being shared are that these structured signals really help smaller judge models align better with human preferences, narrowing the performance gap you'd typically see with much larger models. They also re-emphasize that 28% relative gain on the HealthBench 1K benchmark, showing this rubric-based approach can match or even beat other methods that rely on reference answers. Alright, and this diagram really lays out how the rubrics as reward system works. It's a two-step process. First, on the left, you have rubric generation, where a powerful LLM, guided by human experts, creates a detailed, checklist-style rubric for a given prompt. Then, on the right, you see the training loop. A prompt goes to the policy model. That's the main LLM being trained, which generates a response. An LLM judge then scores that response against the rubric, creating a reward signal that updates the model using an algorithm called Group Advantage Computation with Policy Optimization. Okay, so moving to the results, this table really quantifies the performance on two different benchmarks, HealthBench 1K for medicine and GPQA Diamond for science. The key methods to watch are the rubrics as rewards approaches, especially the difference between implicit, where the judge scores holistically using the rubric, and explicit, which uses a fixed weighted sum. Across both domains, the implicit method consistently comes out on top, hitting the highest scores. This shows that letting the judge model interpret the rubric's criteria is more effective than using fixed weights. Building on those results, this next figure really digs into why the rubric method works so well. It plots the accuracy of different LLM judges across a range of model sizes, from 3 billion parameters up to GPT-4o. And what we see is that using a full rubric, the orange line, consistently improves the judge's ability to pick the better response compared to a simple Likert score, which is the blue line. Even a rubric without a reference answer, the green line, is better than no rubric at all. This structure really helps smaller judge models perform better, significantly narrowing the accuracy gap with much larger ones. Okay, so this next table shows an ablation study, which is where the authors remove different components one by one to see what's most important for rubric design, and the results here are quite revealing. First, generic rubrics perform very poorly, showing that prompt-specific rubrics are crucial. Then, a rubric with only essential criteria isn't as good as a richer one. Interestingly, adding explicit weights or synthetic pitfall criteria, which are checks for common mistakes, didn't really boost performance, suggesting the implicit holistic approach we saw earlier works best. Now, this next table explores another key aspect of rubric generation, this time on the HealthBench dataset. It compares several training methods. We see baselines like expert answer supervised fine-tuning, a standard method where a model learns by copying expert examples, and simple Likert scores. The rubrics as rewards methods clearly outperform all of them, but the most important finding here is that a synthetic rubric created without a reference answer performs much worse. This shows just how crucial expert guidance is. And notably, a synthetic rubric with a reference performs almost as well as a human written one. So, to wrap up, this research on rubrics as rewards shows a powerful way to train models in complex domains without single right answers. The key insight is that using detailed, expert-guided rubrics, especially when interpreted holistically by a judge model, leads to significantly better and more aligned performance than simpler scoring methods. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.